Welcome. So today we are going to start difference equation solution by Z transform. So let's see what we do if we have a difference equation, how we solve this difference equation by transform. So before starting the solution of the difference equation, we just see what is difference equation and how we form difference equation and then how to solve difference equation. Because if we have any function y in terms of x, or if we have any function given, so how we just convert that particular function into the difference equation. So let's see what is the difference equation. So difference equation is actually, it is a relation between independent variable n and dependent variable y. So it is not necessary that we will choose the independent variable n and dependent variable y. We can take any one, like if we are using independent variable n and here is variable x, so accordingly we will write the difference equation. So in this we are treating independent variable as a n and dependent variable as a y. So difference equation, it is a relation between variable n and dependent variable y. We can write example like this: y of n plus 2 means y is the variable which is dependent on n. It means y dependent on n independent variable n. So y n of n plus 2, it means it is a difference coefficient of the two order, second order. It is the first, it is the first order, and it is y. Yn means y dependent on n independent variables. It is n independent and y dependent. So if this type of equation means yn plus 2 plus 6yn plus 1 plus 9yn equals to 2 to the power n. If this type of equation, we call this is a difference equation, not differential equation. It is a difference equation because in this equation we are using differences. This is the difference, second difference, first difference, zeroth difference, means y dependent on n. This type of difference equation we can write in terms of the dependent and independent variable. Now the thing, how to form this difference equation, means what is the formation of difference equation if we have a relation between dependent and independent variable. Like we can just say y dependent on n. It means if I am writing y equals to a to the power n plus 1. So what we call? We call y dependent on n variable. It means y dependent variable and n is independent variable. So in short, this relation we can write y of n. Y of n means y dependent on n. So suppose we have only simple relation dependent on dependent and independent variable we have, and we want to create our difference equation. So what we see here, how many arbitrary constant belong in that relation. Relation means relation between dependent and independent variable only. Right now we don't have any difference equation. What we do, suppose there is only a single constant a. So we will just find out the first difference. So how we find the first difference? We write y of n plus 1. It is yn. So from the one equation, if we are writing the first difference, we just increment ny n plus 1. So this will be a to the power, already we have n plus 1, so n plus 1 means n plus 2. So we have 2 to the power a to the power n plus 2. A into 2 to the power n plus 2. So it means this is first difference. Now this first difference we can write yn plus 1 equals to a to the power n plus 1 into 2. Why we are writing this? Because already we have this relation. So if we are substituting this value from the equation number 1, we have yn plus 1 equals to this 2 we already have 2 into y to the power n. So this is what now? This is our difference equation of the first order. This is not a relation between dependent and independent variable, but it is a difference equation. This difference equation consists a dependent variable y and independent variable n and its differences. So this is our difference equation which contains dependent variable, independent variable and its differences. So what is the difference? Here the first difference. So aim is in our relation or equation, just eliminate that constant. If we are able to eliminate that constant by finding the differences, that particular equation is known as a difference equation. So in this way we can form the difference equation by a relation or by an equation. So if there are more than one constant, like in the next example, we have a relation again or equation again with the dependent and independent variable, and we have two constant a and b. So what we do here, since we have two constants, so to remove these two constants, what we do, we can just find out two differences, right? Two differences means the first difference, this is suppose we are supposing equation number 1. So what we will do, we'll find the next difference. What is the next difference? Yn plus 1. To find yn plus 1, just increment this to the power n by to the power n plus 1. So we have a to the power n plus 1 plus b minus to the power n plus 1. Similarly, if we are finding the next difference, so again incremented this n by n plus 1. So we have n plus 2. This is equals to a to the power n plus 1 plus 1 n plus 2 plus b minus to the power n plus 2. So in this way we have these two equations. Now finally we want to remove a and b. So to remove a and b here, since we have these three equation 1, 2, 3. So there is one way what we can do. We can write the coefficient matrix for the a, b and constant. So what is the coefficients of a? The coefficient of a is to the power n, so write here to the power n. The coefficient of this a is to the power n plus 1, to write to the power n plus 1. The coefficient of a is to the power n plus 2, to write this here. Similarly for the b, the coefficient of b is minus to the power n, to write here this. The coefficient of this b minus to the power n plus 1, to write here this. The coefficient of b is minus to the power n plus 2, write here this minus to the power n plus 2, and the coefficient of 1. So the coefficient of 1 is what? Yn, we'll write yn plus 1 and yn plus 2. This is yn plus 2. And if we are finding the determinant of this, obviously we will get our difference equation, because I think everyone know how to find the solution of the determinant. To find the solution of the determinant, we just take this, multiply this by this, minus this by this, then take minus with this, again multiply this by this, minus this by this, then take plus yn, this into this, minus this into this. And if we solve this, we will get the final solution yn plus 2 minus 4yn. It means that on solving this determinant by the determinant process, we will get the solution yn plus 2 minus 4yn equals to 0. It means that this is the second order difference equation. This can also be written as a yn plus 2 minus 4yn equals to 0. It means y dependent on n. Y dependent on n. But this y is dependent on n with the two differences. So this is our difference equation. So this is a difference equation in which now there is no a and b. We have removed this a and b now. So this is our difference equation. So in this way we can solve many problems related to the dependent and independent variable, and there are maybe the constant, and by removing this constant and writing the differences accordingly, we'll get the solution of the difference equation, or you can say formation of difference equation. So there are two things in this topic. First, if we have any equation depending on dependent and independent variable, first is how to form the difference equation. Now, in the next topic, we are supposing we have already difference equation. मतलब already we have formed. So, how to form the solution of the difference equation? Means the matter is, if we have the difference equation, what is the solution of that? Because in the mathematics, solution is the problem only. For any question, for whether it is any field, if you have given any question, we always write the solution or answer. So you are getting the solution. If you have difference equation, how to form the solution of that? This is a problem now. So to form the solution of the difference equation, which is already difference equation given, we can use many techniques. But since here we are using only Z transforms, so we will use Z transform technique to solve the difference equation, which is already given in terms of the dependent and independent variable. Means we are supposing already we have difference equation by giving dependent, independent variable and its differences. Okay. So we have two methods. The first method is the partial fraction method, and the another method is the residual method. We will study one by one. So in this lecture, we are going to see how to use partial fraction method. So to use the partial fraction method, first of all, we have to see some formulae, important formulae, कि how to take the Z transform and what we get after taking the Z transform. So suppose you have single ym. Ym matlab y dependent on n. Y is dependent on an independent variable. So if we want to take the Z transform of it, so simply we just write the function of Z by using the formula. So this is the notation. So remember this first point. What is the first point? See, always Z by n can be written as a f of Z. This is very important thing. The second thing is, suppose we have the first difference. So if we are taking the Z transform of the first difference, so we write Z by n plus 1, and we have to learn this formula. Means Z of y n plus 1, this is equals to, we'll write here Z and f of Z minus y of 0. So this is our first Z transform of first difference yn plus 1. So this is, we have to learn कि always the Z transform of the first difference is written as a this formula. Now suppose we are writing the Z transform of the second difference. If we are writing for the second difference, to write instead of Z1, write Z2, Z square, same as a fz minus y0 minus y1 upon z. We'll just subtract y minus y1 upon z. So this is the second difference. Now, for the third difference, what we do, like here, z square, we write z cube, same fz, y0, y1, yz, just add here minus y2 upon z square. So this is the third. If we are writing third difference, stop on the second. If we are writing second difference, stop on the first. If we are writing first difference, stop on the 0. So in this way, we'll just learn these formulae and we will use in the partial fraction method. In the partial fraction method, what steps we have to see, just I will clear with the example. How we just solve the question based on the partial fraction means if you are going to solve any difference equation, what steps you will perform for the partial fraction method. So we will see this by the example. So I will clear this particular by giving an example. So we are supposing that already we have difference equation and we are solving it. So suppose this is a question in which we have solved this by using Z transform. Solve using Z transform. This means difference equation. And for this is the important thing. We should have initial condition. Means we are finding the solution UN for some initial condition. So what is the initial condition here? U0 equals to 1 given, U1 equals to 2 given. So what we do, what steps we will perform, let's see. First of all, taking the Z transform on both sides. Suppose this is your equation 1, any equation we can call it this is a 1, equation 1. Take Z transform on both sides in one equation. This is first step. This is our first step. So if I am taking the Z transform, what I have to do? I have to write Z, then UN plus 2 plus 3 times of Z. I am taking Z transform in the first equation plus twice Z UN equals to 0. So this is what now? We can write from the above formula which I explained in the last page. Z of UN plus 2 means just put here Z square Fz minus this question we are solving for U. With the previous one we have seen the function for Y. There is no matter, I have already explained. Here U is dependent on N. N is independent variable while U is dependent. So we have to write this particular Z of UN plus 2 like here. Z of UN plus 2 is Z square. So here we have to write Z square Fz minus U0 minus U1 by Z. So I am just opening directly in the question, the whole thing. So I am just opening Z square Fz. So that formula I am applying. Then Z square. There we are writing Y0. Here we have to write U0. Then Z of there we are writing Y1. Here we will write to U1. Similarly, this is the first part. Similarly, we will just write for this. So already we have this Z. You will just write the formula. So 3 times you have to write 3 times of Z f of Z minus 3 times of Z of U0. This is closed. Why closed? Because we are writing for 1. So we will stop on U0 plus 2. Already I explained what we can write for UN. For UN we can write twice of F because you are taking Z transform for UN. So 2 F of Z equals to 0. Now we have initial condition. What initial condition we have? We have initial condition U0, U1 already given in the question. You can see, just put here U0 is 1. We will put here 1. This is U1 is 2. We will just put here. This again U0 is 1. We will put here and solving it. So what we are doing, I am just writing the whole for the Z square first, then for the Z. So finally, after putting the value, we'll just write Z square F of Z minus first this function. This is what? This U0 is 1. So this is minus 3Z. This is U0 is 1. So this is becoming Z square. So this Z square I am taking on the right hand side. Just I am taking all common Fz. All common Fz. So for Fz, here is Z square. Then the next is 3Z because here is also Fz. Okay. And then I'll write here 2 F of Z. This is F of Z. So I'll write here 2 F of Z. And what we have extra, this minus with minus because you are putting 1. So this I am taking on the right hand side. And again the same, this I am taking this and this u1. u1 is 2. So this and this is becoming 5. So 5 minus 5z I am taking on the right hand side. So finally we have f of z. This is equals to, we can write z square plus 5z and divided by this, divided by, we can write this whole. What is z square plus 3z plus 2. Okay. Now, since we are using partial fraction, so what we can do, we can just take this z as a common from this numerator. So this we are taking here. So we have now z plus 5. Z plus 5. This is z plus 5 because one z I have taken here, and this is z square. Z. For the simplicity, we are taking this z here, and after we will just transfer again. Now we know how to form the partial fraction. So everyone know how to form the partial fraction. What is the partial fraction of this? We can write this a upon z plus 1 plus b upon z plus 2. We can find this a and b. So what we have here, we are writing this equals to this. So I can just simplify this as z plus 5. And if we are taking LCM for this, we can write a times of z plus 2 plus b times of z plus 1. And the denominator is cancelling with this. So finally what we have, if we are putting z equals to minus 1 in this relation, we'll get the value of, what value we'll get here? We'll get the value of a. The value of a is now, the value of a is 4. If we are putting z equals to minus 1, this is cancelling. And here is 4. So what is the value of a? A is 4. Similarly, if we are putting z equals to minus 2, this portion is cancelling. We'll get the value of b. So what is the value of b? The value of b is minus 3. After solving, we can solve this. So finally, what we have? We have the equation which I am writing here. You can see fz upon z, which is this here, and this is equivalent to this, and this equivalent to this. So finally, I am writing directly 4 upon z plus 1 minus 3 upon z plus 2. Okay. Or what we can do, we can just write the c by transferring this z here again. So if we are transferring this z again here, what we'll get, let's see in this equation. The next equation, what we have, f of z equals to 4z upon z plus 1 minus 3 times of z upon z plus 2. Okay. Now, what is f of z actually? You know, z of un, z transform of un. In this, here u is dependent on n. That's why you are writing. And this is the formula. If we are writing this in terms of the formula, we can just write z minus 1. We can write this. Similarly here, we can write, why we are writing? We are making the formula of the z transform. So what we can write? The z transform of this, if we want to solve un equals to, we'll write here z inverse of the thing which you have written here, okay, minus 3 times z upon z minus minus 2, close bracket. Now taking the z inverse transform, we are just taking 4 outside, it's a constant value. And the z inverse transform of this is minus 1 to the power n. And here also we are taking minus 3 out. The z inverse of this is minus 2 to the power n. And where, what is the n here? The value of n is 0, 1, 2. Because we have initialized u of 0, u of 1. That means obviously the value of u and n should be 0, 1, 2, 3 and so on. So in this way, this was one example. This is our answer. This is the solution of the previous difference equation. So in this way, we can find the solution of the difference equation by any method. Means we have two methods. One is partial fraction method and another is critical. So right now we are studying the partial. We are solving by the partial. Now I am writing one question. Using Z transform, solve un plus 2 plus 4 times of un plus 1 and then plus 3 times of un equals to 3 to the power n. With a condition, there are some initial condition. Condition I am writing u0 equals to 1 and u1 equals to 1. Okay, so for the solution part, what we can do, I am writing the steps, I am revising the step for you people. What we will do, suppose this is your equation number 1. Take Z on both sides. On both sides of 1, in equation 1. The second, after taking Z transform on both sides, using initial condition which is given here, this condition, using initial condition. Third point, write equation for fz, please write fz on the left hand side. Then using partial fraction, find out fz in terms of fraction, partial fraction. Okay, then after that write fz. Okay, write fz completely. Write fz and take inverse Z transform on both sides. And final, the sixth step, getting the solution of difference equation. Okay, so in this way we can use all these steps to solve any difference equation with the initial condition by using Z transform. So for this method, first of all, clear, your partial fraction should be clear. All the cases of the partial fraction should be clear. So the first partial fraction case is the linear factor. The second partial fraction case is non-linear, means repeated factor, partial fraction with repeated factor. The third case, if in the equation factor is like a quadratic equation, Then how to find the partial fraction? This is the third case. The fourth case, if there is a repetition in the quadratic equation, like suppose there is given an square plus bn plus c, and it is repeating square, cube, like this. So this is called repeated 2 times, 3 times quadratic equation. So there are different cases for the partial fraction. So accordingly, we have to use the Z transform. So for the Z transform, first of all, we should clear how to find the partial fraction for these 4 different cases. So if any one case is, if we have to apply any one case to solve the solution of the differential equation, so that from that method only we will just solve the partial fraction, and then just taking the Z transform, and after that taking the inverse Z transform and getting the result. So in this way we can solve difference equation by this method. So please try to complete this question and getting the result. So I can do one thing, I can also write the same answer of this question for you people. So I am writing the answer for this question. The answer for this question is 8/3. You can note, or just I'm writing here. I'm also writing the value of ABC. Whatever the value of ABC we are getting, I can write here. So I think this method is very simple. If we are using this particular method, it's very simple. But as per your choice, because we have two methods. One method is partial fraction. Another method is the residual method. So whatever the method you are liking, you can use that particular method in the examination. And one thing is, suppose in the examination we have asked using the residual method only, write the solution of this particular difference equation. So what you will do, you have to use that particular method only. We can't use the method of the partial fraction at that time. Okay. So this is question un plus 2 plus 4 times of un plus 1 plus 3 un with the initial condition. I am repeating the initial condition. U0 equals to this you can do here. You can just put here 0, because from 0 you can get the answer fast. So for the practice purpose, I am giving you U0 as a 0. And you can take U1 equals to 1. And the same question will be there. What is the question? I am repeating again. Un plus 2 plus 4 times of un plus 1 plus 3 times of un equals to 3n with the initial condition u0 equals to 0 and u1 equals to 1. So we have to find the solution of this difference equation by the method of the partial fraction. So I am writing for you people the value of a. The value of a you will get here 3/8. The value of b is minus 5/12, and the value of c is minus 1/24. This you will get. Okay. And what is the solution you will get, that I am also writing. The solution which you will get here will be un equals to 3/8 minus 1 to the power n minus 5/12 minus 3 to the power n 1/24, and here 3 to the power n with n equals to 0, 1 to 3 and so on. So this is the answer of this problem. So I will hope you people can solve this particular difference equation by using Z transform, by using partial fraction yourself. So please try the method. I have already explained the steps or also written here. You just try to find out answer also with you. So repeating what is A here, the value of A. I am just repeating the value of A is 3 by 8. B is minus 5 by 12. And C is minus 5 by 1 minus 1 by 24. And you can also check with you whether I have just written this value correctly or not. You can also check with you, because I have just found this solution and I'm writing here A 3 by 8, B minus 5 by 12, and C minus 1 by 24. You can also correct with you. So thank you so much for watching this lecture, and hope you will enjoy